Hello everyone, hope you can see me all well. Please let me know where you're watching from. Unfortunately, Alex is sick today, so I'm doing it all by myself. So let's just let it be to be fun. So welcome everyone, and I just wanted to say happy new week. I think the weekend was pretty busy. For once, Europe switched to daylight saving times, and this is actually not my best move forward, right? Because it's early at night still. So I'm more like late night person than an early morning person. So it's not so easy for me. Let me know where you're watching from and if you can see everything. So it seems that Greenland moved to a different time zone and they don't need to do DST switching anymore, which is really cool. The other thing that happened on the weekend was, let's see, I went with my kids to see Dungeons and Dragons preview, and it was really good. So if you haven't booked in preview yet or haven't planned to go, I can definitely recommend it. It's funny, lots of action, good dialogues, good special effects, and really nice spirit of D&D roleplay games. The only bittersweet thing is that it's kind of all Hasbro and not independent, but that's capitalism for you, I think. Anyway, that was a good one. The other thing that happened on Saturday is the asteroid that's between Earth and the Moon, actually closer to the Earth than to the Moon. And unfortunately, it was all cloudy here. I couldn't see anything, although I went out like late night and hope some of you were able to see it. Let me know in the chat if anyone saw the asteroid via telescope or binoculars. I would be really interested in that. And yeah, I was unlucky. I could only watch like some YouTube videos and so on. So that was a little bit unfortunate. The other thing, I'm also using a new browser, as you can see. So I moved from Brave to Arc. And so far, it's been really fun and good. So as you might have remembered, I have this kind of problem with browser tabs. So my last Brave session had almost 1,500, I think, browser tabs, which are a lot, and which also took a lot of compute resources. And so Arc promises to auto-archive tabs that are longer open than you specify. It has a lot of good features and keyboard commands and multiple spaces and all this kind of stuff. So let's see how long this shiny new toy works for me. But if you want to get an invite yourself, because everyone is only getting 5 invites to friends, you can go to Lenny's podcast. And in Lenny's podcast, there's an early access to Arc. So if you want to get an instance of Arc running, you can go to Lenny's podcast and the episode with the CEO of the browser company who builds Arc. And you can get the early access there. Hey, Kin, watching from Australia. I remember fun times being in Sydney and Melbourne and Brisbane. Good to see you. And Tislov, how to work with time series in data in Neo4j. That's a full episode in itself. Just let me say quickly that there is actually datetime support in Neo4j, so you can basically store events with datetime information in the graph as nodes, and then you can either connect them with next relationships, or you can use a date time range index. And then you can do that aggregation window functions and things like that from loading it from the index. And if you basically store on the node only the datetime information or the time as a long value and the actual value, then it only takes very little memory on disk as well, and then you can use that. Our operations manager that we just released. Now let's take this one. It's actually using Neo4j to store time series data as well. So if it works for them, it should also work for you. Of course, it can't do the right performances like a real time series database. So you wouldn't want to replace InfluxDB or time series timescale with Neo4j, but rather combine it and move the aggregated information into the graph as a high value thing. We don't have yet another episode on time series. Last time we did a little bit of daytime. The Bloom tool can now support time slices or time sliders as such for visualization of time invariant graphs. But I think there is some content on the YouTube channel on time management in Neo4j, and there are also a number of Medium posts. If you look for, where's this here, daytime? So my colleague Jennifer did a number of articles on date and time management, but not as such time series. So there's the time travel blog post, which is from recent about the tool, the Bloom tool with time slicer and time zones, but not a real time series one. But we can keep this as one of the recommendations. Cool. And with that, I think I covered all things from the weekend. I hope you had a good weekend as well. And today I want to talk about something interesting, which is Git Log output. So as you all know, version control and especially Git also forms trees or actually graphs as well, with the each commit pointing to its parents' commits. And I thought that could be a fun thing to look into as a graph, and that's what we're going to try to do today. And let's see how far we get, and then we'll run a bunch of fun queries on top of that, and then we'll take it from there. Actually, perhaps you can look at the Git commits a little bit as a time series equivalent and see if that already answers some of your questions. And then we can basically, it's similar to the chat reactions as such. Okay, how are we going to do this? So first of all, of course, we log into Aura. So if you go to Neo4j Aura, if I log out again, I can do this actually, log out. You would basically sign up with your email address or with your Google account. And I can just sign in with my Google account. And then you would go to create new database after it loaded. So you would say a new instance, and then you can create a new instance by clicking, for instance, here on empty instance if you just want to have an empty one, or if you want to have a preloaded data set, you pick any of these. So for our needs, we would create an empty instance. And for this empty instance, we get credentials, and we can actually download them as an env file. So you can use them with .env, for instance, in JavaScript. So I can download this file and then just continue. And then it creates this new instance, which has nothing in it yet, and sets it up. Okay, while it's doing that, we can look at the Git history. So if I pick a Git repository like the Neo4j Git repository, I can run Git Log, and you see like commits there as such. So you have a commit ID, you have some ref log information, you have an author and an issue and a date. You can also turn this into one-line outputs. Type one line. Then it basically does git commit and message only. But what is much more interesting is using Git Log with Pretty format. So you can basically specify in your own output how you want to do this. So for instance, I can say, let's see here, pick something simple. Let me remove all the other stuff that we talk about in a second. So for instance, if I just want to have something like this, author name, author date, and let's say just commit. So this would output our commit hash, our author name, the date of the commit, and the Git log message, and then use the commas as separators. So this could get us a kind of JSON, CSV that we need for importing into Neo4j, but it wouldn't escape things if there are commas in the message or so. Then that would not be so helpful. So if I output this and let it give me like the top 2 lines, then I see the commit ID, and I had made a spelling mistake here. So it's %author name. So I see the commit ID, the author name as we saw before, the date as ISO string, and then the text as such. Right. So we could use this already to get a CSV kind of format out of Git logs, but the problem is that if there's a comma in the commit message, then this is not so good. So on the weekend, I actually saw here Simon Willison, the author of Dataset, and the guy who's doing a lot of fun stuff with GPT, share this bit of information where he basically, instead of using commas between the elements that you output, uses actually the null byte, so like the 0 byte, which you can then use other tools to split on the null byte and generate something, right? So here in this example, he generated JSON from it. So he basically does this output that you just saw, just instead of commas with null bytes, and then uses JQ to split it by the null byte and then output the different elements as commit, author, date, and message JSON. And if you were to run this, just put this out here, and we just use head -2 again, but that it doesn't scroll so much, then we can actually see that this turns it into JSON, right? So we have our commit, our author. This is not the author, right? So because that's our parent ID. So because I changed it already. So let me remove the parent ID here. Let's run this again. So now we see our commit ID, our author, the ISO date, and the message, right? And even if there's a comma in between, then it would still work. Cool. So this gives us like a JSON output, but with Neo4j, the built-in tools import CSV, so we need to use CSV instead. And fortunately, JQ is really a Swiss Army knife, and you can also generate CSV from it. And so what I did is, let me actually just paste some of the links into the chat. Neo4j.com, or for Aura, you use console.neo4j.io. For let's see, Lenny's podcast, you can share this as well if you want to, for the access to org. And for this article, that's this one here. He has a lot of really good stuff, so please check out his Today I Learned blog, and also his general blog. Really insightful, good data articles as such. Okay, and all these format strings in Git Log have their different options for putting in placeholders. So you see that we used so far the commit hash, we used the author name, and we also used the commit subject line here, right? The other thing that I want to add to make it a graph is the parent hash. So we basically have the commit hash of the actual commit and the parent hashes. So that could be also more than one. So that's something that we need to look out for. And then the other thing is the author date in ISO as such, right? So that we can use. And there's more stuff that we can output. Adding file names to this actually takes a little bit more fiddling because it's not part of the placeholders. That's why I left it out for today. You would have to basically output the file names and then run an org script or something like that to turn this into a CSV, because you also have to repeat all the metadata for each file name again. But it could be interesting if you want to look at distribution of commits across the code base as such. Okay, so if you want to see this cheat sheet, I'll also put it into chat as well. Quite useful. So what I did is the following. I basically echo just the sorry, our column names into a CSV file. So I just do echo commit, parent, author, date, and message, comma separated into an Neo4j Git CSV. And then we use our Git log with pretty print format with commit, parent, author name, author date, and commit message split by null bytes or separated by null bytes, and then pass it to JQ and tell JQ read in raw string, not JSON, output a raw as well. And then basically as operation, split it by \n, so the new lines, except for the last one, and then basically split it by the null byte for each line, and then take each kind of split line as an array and output the things here that I want to output, right? So I could also select to only output the first and the last or something like that. So I could actually save this bit of selecting things, but I wanted to make it explicit what I output. And then I pipe it into the CSV operator, which turns this all instead of JSON into CSV and append it to the Git log CSV file. And as a repository, I just picked the Neo4j public repository. So it has 76,000 commits. So that should be enough for our demo graph. So let's see how far we get with this. So if I run this inside of the Neo4j repository, this one, then it runs for a few seconds and then generates a CSV file. And if you've been here before, you know that I really like to use XSV to look at CSV files. So I can say, for instance, XSV count home downloads Neo4j CSV. Oh, sorry, news. What do you call it? Sorry, Neo4j Git CSV. Sorry, CSV. And it says 76,000 lines in the CSV, so it seems to have gotten all the commits. And I can also run XSV stats on this file, and then it would show me like the field type or the field name, the field type, sum of values. Min max is not so interesting, but like what's the standard deviation and an element as well. So so I see kind of how many different unique values are there and things like that, so which is kind of useful. Right, so I see this is kind of the content. I can also say XSV select or table or something like that, and then you know, or do a subset of that. Actually, for XSV, if you want to see more about it, here's the as well. Quick. So it's written in Rust, so it's also quite fast and has, as you can see, a lot of interesting things like kind of outputting, sampling data, formatting, reformatting data, table outputs, joining different CSV files, searching. So you can subselect basically. You can also subselect columns or rows, and you can take slices basically as such. Sorting and so on, or splitting into chunks, which is something that we've done in the past as well if the data was too big as such. Okay, so that's XSV. We get our CSV file now, and in Aura, our instance is now running. We can rename it to Git Logs or Neo4j Git Logs. And then here, click on Open, which will open Neo4j Workspace. And in Neo4j Workspace, we need to get our password, and I downloaded them. You can just take this file, password from the file and connect to my database. So you don't need to look at it. I'll delete them afterwards anyway. To input our data, we go to Neo4j data importer and think a little bit about what would the graph look like. So we can add our file here from downloads, And we see our commit, our parent, our author, date, and message. So that's what we would probably have. We have like a commit node, right? We have our author as such as well. And then as relationship, you have also the parent commit. So you can either do something like you pull out of your node with this kind of halo that appears here. You can pull out new nodes. So either I pull out a second commit node and map this, or I could also do a self relationship where it's basically pointing to commit, basically. That would also work, right? And our author is over here. So that's basically this. And so the graph model looks pretty simple, but it's a large tree basically that we have from Git. So if you want to map this data, we would say, okay, if I want to map the author, it would be basically just be the author name, and that would also automatically become my ID property down here. I didn't put in the email addresses because I didn't want to expose the email addresses of all the people. Also, you can get them from Git Log, of course. And for the commit, I do the same. I map the commit ID as the ID and map the date and the message for the commit. Right? So currently it says the date is a string because it misses the T here in between for the ISO date. But we can try actually to tell it to make it a date time and see if it actually works. And the commit string is an UUID hash, of course. So that's also mapped as a string. And then we have some relationships like here. We would probably point this in the other direction. So I just say switch direction, and I can call the relationship. I can enter the name here or on the relationship itself. Something like authored or committed or wrote. It's probably easiest for me to spell, right? Commit, we haven't selected an ID property because if you do, so then this becomes solid and pointing to the commit because both nodes now have an ID, and so we can map the relationship. So I could rename this also instead of commit to ID, but I leave it as commit hash, or probably we probably want to call it like hash or something like that. So commit hash is our ID, and here's our author ID. And then for the self relationship, we would say from commit hash actually from the file to the parent is our relationship between the two, right? And then we just say here parent commit, right? So that's basically pointing from a commit hash from the commit file as such to another commit hash, which is in the file represented as a parent, right? Ashwa, you're asking about, this is all JavaScript. So these tools are written in JavaScript that I'm showing, but of course you can all do it all in Python as well. So if you go to your Aura database, you see Python example code here. And also if you scroll down, there is a really good online course for Python development. And there's also Python documentation here. So for instance, if I go to, where's it? Why didn't it open the course here? Graph Academy. It should actually open Graph Academy such. Okay. So here in Graph Academy, so if you go to graphacademy.neo4j.com, then you can basically see the app development code for Python, and that explains you how to use it all from Python as well, including driver, result processing, and on all the other things as well. Okay. So that now means that we have mapped our data, and now we can actually look at a preview of the data. So we can click on preview, and it will basically run and first few thousand lines of the data will be run as a virtual import. It's not really imported, it's only virtually imported. So you see, and this resulted in 151 commits and 33 authors and 150 parent and 350 wrote relationships as such, right? So if we zoom in a little bit here, we can see some of the people. So the turquoise ones are like our people, our authors, and the brown ones are our commits. And if I click on one of these, I see kind of this is the date. So it seems to have parsed the date correctly. We have our commit hash and the message as well. So that looks good. And then we have basically on the author, we have only the author name because you didn't store anything else as such, right? And we have the relationships between author and commits. So authors wrote commits, so they authored them actually, but I don't want to spell this out every time. And then between commits, we have parent relationships as well. So that looks good. There's only one thing that I want to see is right now we only use the parent thing as the relationship connection, but because Git can have multiple parents, let me also add this as an additional field to the commit, so that we can look at if there's like multiple parent IDs in here, that we actually fix them up and also connect them to their parent commits as well. So I can preview this again, and this wouldn't change the picture as such, right? So because I'm just added a new property as such, but this is how I can see if I made any mistakes in the mapping, right? So if I, for instance, did like the direction of the relationship in the wrong direction, or if I misspelled the property name or something like that. You see this on the preview already. Okay, and then can click run import, and it will go ahead and import the 76,000 nodes, and it will take a bit because that's quite some data. So you can actually look at how much data it is. So if you do so it's 40 megabytes of data that are imported. But you see it's making good progress. So it now imported all the nodes, and now it will import all the relationships as such. So it has 2 relationships per commit at least. So the author relationship and the parent relationship as such, right? So it will be 76,000 plus the author node. So it's probably 77,000 nodes or something like that, plus 140,000 relationships in total that it imported in 40 seconds. And here in the input results, you can see it created 76,000 nodes from the 76,000 file rows as such. It created 338 authors, so that's all the people that contributed to Neo4j as such. And then it created 76,000 road relationships and 61,000 parent relationships. So you see there's some missing. So that's probably the ones where we have a double parent and it didn't resolve them. So we can do this later. And it also shows every time how much time it took for inputting this data. So it's pretty quick for the authors, of course, and the relationships are 10 seconds each, and importing the 76,000 nodes took 19 seconds, mostly because of the additional string properties. So we can also look at what kind of commands it executed that you then can also put into your own script if you want to import something similar. So it first creates a constraint for each of the nodes for the ID. So in our case, it's the commit hash and the author name as such. Of course, you know that author names are not unique, but in our case, it's good enough, and I didn't want to expose the email addresses. The other thing it does, it takes batches of lines from the CSV and sends them in as parameters. That's also a good pattern in general to do this as a batched import. And then it basically looks at some stuff that it can skip, like empty strings for commits and so on. And if they're null, and then it merges, so that's kind of get or create or upsert each commit by the hash. So if the commit already exists, then it doesn't create a new node, but it just gets this back from the database. And that also means if I run this import again, I can basically run it as many times as I want. If I want to change things, then it would not, add the data again twice, but it would kind of reuse the existing data that's in the database as such. And then it sets the properties, date time for the date, and the message and the parent as strings here. And for the author, it's similar. It just sets instead the author name as the information. So if you don't want to do it like this, you could also replace the unbind here with a load CSV. load CSV from file URL as node record, and then the rest stays the same as such. So Ashwa is asking, how can we find any errors? So I just showed you the preview, and basically the graph model is something you need to know from your domain anyway, right? So you want to, if you want to import data into a database, you need to know what your domain looks like and what your model looks like. So from that perspective, you have already discussed, the model with some colleagues or friends, drew it on a whiteboard and kind of discussed kind of how do we want to model this data, and that's what you do in the UI here. And then the preview shows you did actually data that went into the database equate to the model that you draw out, and then is how you can spot errors. If there are other errors, like data errors or so, then they would show up here in the input results and would say, hey, I couldn't import this data because of error message XY, and then you can look at this as well. Okay, if I click on Start Exploring, it gets me to the Explore tab in Neo4j Workspace. And in Explore tabs, there's something quick, which is called Show Me a Graph. And if I run this, it kind of basically gets me a little bit of a graph. And you see here are the yellow nodes or the author nodes, which I can also basically give an icon as well. And I can use the author name as a text. And for the commit node, I could use as an icon. What do you want to use? A hammer? I don't know. That's a commit. It's a hammer now. And the text would be either our commit hash, but probably like the message would make more sense from this, right? So we can also make these commits a little bit bigger, and we can also make the authors a little bit bigger. You can also give them sizes based on values as well. So there's role-based styling as well that you can use here. And so you see that some people have been pretty busy here, but it also fetches only a subset of the data, right? So you can see that. But what you can also see is, for instance, if I pick like one commit and another commit, I can also say, find me the shortest path between these two commits. And as you can see, there's actually a really shortest path between these two because there was actually one was the parent commit of the other one, right? So that was actually, I didn't expect that. So let's pick some other commits like this one and this one, or like, come on, this one and this one. And if there's a connection, it should also show me the shortest path between these two, right? So, and you can see if I dismiss all the other nodes, this is basically the shortest path between these two commits, right? So I can basically find patterns already in my commits as such, right? Which is interesting. So, and you see that these form these kind of long chains of commits. So, for instance, if I say, if I clear out this scene and say I just want to see parent commits, it should give me a lot of long chains, basically. So it fetches like 1,000 nodes by default. And you see it's basically long chains of nodes here. If I pull this out, you see basically it's a gigantic chain of data, right? Actually, I wonder what happens if I pick, so this is like live demo now. If I pick an hierarchical layout, so let's see what happens there. So it's probably too much data to make any sense of it, but it should be like a really long tree as such. Okay, let it run in the background while it's running here. We can go over to the query tab actually and start looking at the data a little bit from a query perspective and fix the parents commits. So let's find first how many commits we have in our database. So we say we use our Cypher query syntax. We use round parentheses around nodes. And then we just pass in colon label. So commit is our label for the node or type. And then we give it a variable, which I could even leave off here. So this is our node that I'm looking for. And then return count star just returns the count. Yeah. I'll do that. If I forget, please let me know. I'll can upload this data as such. But it's 14 megabytes, and you can generate it pretty quickly yourself. So I'm not sure if you need to upload it as such, but I can actually put it into GitHub into the repo as a short blog post, and then you can do it yourself as well. For any other repository, of course. So if you have a repository that you really like let's say the React repository, or whatever TypeScript or whatever's interesting to you, or the Linux kernel. So it's 76,000 commits here, and we can also look at how many authors do we have. So if you say how many authors do we have, 338, and we can also see, for instance, what are our most prolific authors. That's actually an interesting one, right? So we say basically we find our authors and say what's the degree for our author, which is basically the count of wrote relationships, right? So this author wrote commits. This is our degree. Right, the number of commits, or we can also say commits. So we just spell out this pattern here. So we have basically the round parentheses around nodes, and then arrows for relationships. So basically it's just a double hyphen and greater than sign. It's relationship. And if I want to be more specific, then I put in square brackets the additional information, like here the relationship type. And then I can say return me the author's name and commits order by commits descending limit. And so these are the most prolific, 10 most prolific authors here. Author.name. So if I do this, then I see there's nothing because it's not called names, but author. So Matthias has been with Neo4j for 15 years now, even more than I. So he's the most prolific author. The other one is Anders, one unfortunately died of cancer a few years ago, and he was also one of the first employees at Neo4j, doing amazing work with the documentation at Neo. Pontus and Misha are also a long-time Neo4j engineers, who've both authored 4,000 commits, and Andres, the father of Cypher, as well, and Chris West, who worked in the kernel, page cache, and things like that. And my friend Jake, who has also been with Neo4j for a long time, has also authored a lot of ones. And Anton actually did the same. What's interesting here, we have Matthias Persson, and he got married and took the last name of his spouse. So Matthias Finne and Matthias Persson are actually the same people. And so the question is, could we actually merge them together, right? So because we know that it's actually the same person, we should be able to actually merge them together. So let's perhaps try that first, so that you can see how you can actually fix up a graph. So let's see, we find our Matthias, our author Matthias Finne, and our second author, the old one, basically, Persson. Matthias Persson. Did I misspell it? I did not return it. So these are our two author nodes, and they have both a lot of commits. And I want to move the commits from the old Matthias node to the new Matthias node. So what I do now is basically I match the old Matthias node, which relationships to which commits did he have, right? And what I do is I'll move them over. So I basically create a new relationship between the author, our new author. Let's call this one new. New wrote commit, and we delete the old one. And so for each old relationship that existed, that we find between the old node and the commit, we delete them, and we add them between the new node and the existing commit, right? And if you run this, let's see, we probably don't want to return all the data. We just want to return the count of how many times did this happen. And if you run this, it should take a few seconds, and then it basically created 6,500 relationships and deleted 6,500 relationships, right? So that means if you run our statement here again, then Matthias should be on top with 8,700, and his other node is still around because we didn't delete the node, but we could do this now. So that now it's more accurate description of this. So we could probably do this also for some other people who got married or changed their names for other reasons. If you remember, we also wanted to look at the parent commits. So we can find nodes or we can find commits where not exists, and we say we have actually commits that don't have a parent. Right. Return C limit 20, and if you do this, where not exists. So these are nodes that have no parent commit, and we see that's because they have two parent commits here, right? Is there actually a comma? No, is this a new line between them? Let's see what's in there. Space in between, right? So you see there's a space in between. So we basically need to split them by space and then reconnect them as such. Okay, what we do is we find these nodes that don't have parents. And we also want to say c.parent contains a space, right? So because then we know that's one of those that has a space. So we can count how many commits of these types we have. Return count star. We have 15,000 commits that have more than one parent and that were not mapped here. Okay, cool. And what we now can do is actually we split this parent field by space. And for each of these entries that is generated, then we find the parent commit and connect our commit to it. We want to split c.parent by space as parents. And we just use the unwind function, unwind clause, sorry. I've wrote it myself and I don't even can say what it is. Unwind parents as parent. So this is our parent hash now, right? So we have basically, actually let's do a subset so you see what it looks like, limit 5. And then we can return basically the commit, c.parent, parents. Let's see what this does. So this is our commit. This is our field with the space in between. This is the array, this array that comes out of the split with basically both parent commits in an array. And then our unwind turns this list or this array into rows. So basically we have a repeated 2 rows where the first 3 elements are the same. And the second element is basically the first entry and the second entry here. Right? Okay. And now we can basically find our parent commit. Parent commit where the hash is parent. And if we found one, then we can basically create a parent relationship. Parent relationship between our commit and our parent. And then instead of returning the data, we return count again, right? So let's do this for these 5 ones. So it should basically 5 times 2 probably create 10 or a little bit more if it's more than 2 parents 10 relationships. So it actually created 10 relationships, and now these 5 nodes have a parent relationship, right? So which is great. And now if I remove the limit here, So you can either comment it out, or I can also just delete it. Then it runs, and it should create perhaps 30,000 relationships, right? Yeah, 30,500 relationships, right? So we might have some commits which have 3 parents, but most of them will only have 2 parents as such. Right? So that means we fixed up our graphs, and then we basically think it gave up on the hierarchical layout, right? And now we can do fun things. So for instance, we could say if you find 2 authors, for instance, Matthias and Andres, so return A, comma B. So these are our author, not name. I should have renamed the field. So we have Andres and Matthias, and if you want to see how are they connected, right? What's the shortest path between them? We can basically run another match that says path equals shortest path from A, following only. It needs to follow both relationships, because otherwise it wouldn't. Except if the co-authored stuff, then road relationships should also work. Let's see if they co-authored something like that. So between A and B, we have a shortest path, and return our path. So it finds only one path, so it's safe to return that. And so this didn't return anything. So because it seems that we don't have co-authorship in our data. So if I just remove this, it should give me any shortest path. And here we see there's 2 commits from 2013, so very early ones, from Andres and Matthias. That's about adding the label plus equal clause to Cypher, where we could add labels, or where we can add labels, and then transaction context commit for Matthias, right? So one is kernel, one is Cypher, as such. Because we also have datetime information on our data, we can also look at like distribution of commits per year. That's also something interesting. So we can, for instance, say find our commits, and we just return C dot date dot year count star order by year ascending. Then we see basically how many commits happened in 2007, in the early days, 2008, 2009, and so on, right? So this was basically 2008 to 2010, if I remember. It was actually, I think, to 2009 was SVN Subversion. We had used Subversion back then. And then we migrated to Git, first our own Git instance, and then to GitHub. And you see basically that this was a lot of commits in the early days, and then we had a few years with 3,000, 4,000 commits, and now we have between 8 and few thousand. So this went down because of the mirroring of the private repository to the public repository. So many commits go into the private one, and then like half of them are mirrored to the public one. And already in 2023, we have already 535 commits as well. That's actually something that we could also look into the history. So if you look at what we had here, we could also say we only want to count author dates that are older than a certain year. So I could, for instance, say where c dot date is greater than date time of date. Let's see, 2000. Let's say since 2019 or 101 or something like that, right? So we have basically a date. We turn this into date times for the comparison, and then we only want to count the commits after 2019. And if I didn't misspell anything, cannot select datetime from why not? That's interesting. Was 190101? It creates a date. It's weird. Okay, I don't know why it's misbehaving as such, but we can basically also pass in ISO date here into the datetime itself. This is T, and then basically 0000000. This works. Yeah. So I need to check why it didn't do the datetime of a date. It should actually have worked. So we see in the recent years, Misha is more active or has committed more. It's not mean that he's more active, or he authored more commits than Pontus and Matthias. And other folks are coming up into the list, like Luis here and Therese as well in the top 10 list too. Okay, super. The other thing that I wanted to show you is I think this layout is still running, so we just switch back to 4-space layout. The other thing that I wanted to show you here is kind of the time changes over time. So we have all our parent commits in here, or not all of them, but a number of them. And if we want to basically see how this changes over time, this graph, coming back to your time series question before, we can click on this slicer button here, down here. And we can add a range. We just say commit date is our new range. And this gives us an, actually, I don't know why it's now showing up here. It should actually show at the bottom. I think this is a render bug, which is interesting. That might be actually a really interesting render bug in Arc. I'm not sure what's happening here. So I can basically add the range here and then say these are the counts per day, basically, per date. Right? So from 2020 01 all the way to 2 weeks ago or something like that. Then you can basically subselect this as well. So this is now showing only, does it say here how many nodes? It should show somewhere how many nodes it shows. And then if I hadn't had this render bug here, I could actually play this as a visualization, but for some reason it doesn't show the graph anymore. It's a little bit unfortunate. So let's see if it works in Safari. Don't want to open Brave because then it reopens all the 10,000 browser tabs, which is not so helpful. No, I don't want to log into Okta right now. Okay, so if you want to see this from last time, we did the time slider. So I'm sorry for the render error here. But what it does, it basically shows the nodes that are only visible in these segments as such, right? Which is quite nice. So you see how the graph evolves over time. And I talked to the team about the render error here. So I can actually try to shift reload this and see if this helps. Sometimes, as you might know, there's JavaScript, new scene, parent, yes. Perhaps also the layout thing that we had there was still, okay, this looks better, right? So now we have our slicer at the bottom, and we can select the commit date here. And if I select a subset, you will see that the other nodes are hidden away. So we have only like a few nodes here. Let's say we take 3 days or so worth of data. And if I start playing this, then you see how the graph changes over time, right? So some nodes go away, other areas are getting into it as well. Right? So that's how you can see how graphs can change over time. If you want to change how this is rendered, you can also say, instead of sliding, I want to basically expand this range as well. And we can also change the playback speed to make it a little bit faster. And then if I play now, it will actually expand it. So you see how the graph grows time over time. Or the other way around, you can also say you start at full range and you see how it shrinks basically going to the future as well. So this is quite useful for time-based information in Explore. Cool. And with that, I think I covered most of the things that I wanted to see. Oh no, let's see. The other thing that I wanted to show is I wanted to see kind of if I look between commits and their parents. So we know that there's an commit to parent relationship, right? Return path. Right? Oh, sorry, I didn't want to return all of them, but it basically did. So this is kind of stressing out the visualization a little bit. So let me just close this window and just let's limit this to 20 or so, right? So we see basically a long chain of pieces, basically one after the other, basically commit to parent, to commit to parent, commit to parent. But what you can also do is basically, I want to see this as one path, right? So this is only one commit to one parent. So what I can now say is basically, I want to see 0. I want to see 10 hops away, right? So then it basically gives me like a 10 element path. Right? So if I want to see now, for instance, how many which commits are like the root nodes that have like most children or something like that, right? So I want to say this is my root node and this is my children, right? So I want to actually see instead of returning the path, I want to see which root nodes have basically count distinct commits as children. Return p, comma, children, order, children descending, limit 10. So these are the root nodes that have most children, right? Which is really interesting, and because it's quite large data set, as you see, 76,000 nodes and their relationships. So let's see how long this takes. So it goes over all the commits, and we can actually look at the, so it already returned it. So we have some, so it took 5 seconds, and if you run this again, it can actually be a bit faster. 3 seconds. So we have some root nodes that have almost 500 children, and then it goes down to 300 something as such, right? And what it does under the hood is I can run this with profile. Then it shows me actually what's happening behind the scenes. And if you now look at the plan, we see basically we find all the nodes. So it goes to all nodes, which is already a lot. So 76,000. Then does an one length expand with an optimization. And then gets 1 million nodes out of that, and then it basically filters by the end node and counts and sorts basically by this as well, right? So that's nice. If I remove this, this should be a bit faster. And if I basically use something like this, let's see. This takes 3 seconds. So that's for all of them. And if I had a subset of parent nodes, for instance, so if I say take only, say, limit 100 parent nodes or something like that, then this should be with P. Yes. It's pretty quick, right? So because then it only has to touch a few of them. But what I want to do is I want to remove this limit of 10. So I want to give it like the option to go all the way down to its children. And you see that it's still instant. But the data that comes back actually shows us that these have like 100 level deep paths, right? So that's actually quite interesting. So that it does for these 100 nodes, it goes 100 times 100, like to max int down the path, and then it basically connects all of them, and then we just count them as such, right? Which is quite nice. That's a recent improvement with the that you don't have to specify upper limits anymore here for the variable length path. Right, and if I do it for 1,000 nodes, then it's still fast enough. It's less than a second here, or half a second actually, which is quite nice. Cool, and with that, I think we are at the end. I hope you enjoyed this session, and I'll put the data and the scripts up to the GitHub repo. If you want to follow us there, you can do that. And otherwise, we also have a Discover Aura free video page that I also put into chat, and then you can and here we also link to the GitHub repositories and articles. We've also written a number of articles about the different ones. I don't always get to writing the articles, but I try to put in at least some data into the GitHub repository as such. Cool, and with that, thanks a lot for watching. I hope you enjoyed this, and if you have suggestions on what we could do next time, just ping us on Discord or on the community, and hope to see you back in a week or two, and have a great day and a great week. Bye-bye, everyone. Take care.